Well, anyway, let me just get started, and then we'll catch up. I am Billy Jitsu on the internet, smart contract developer. I work for API 3 as dev relations and dev advocate. I also work for Developer DAO as hackathon coordinator. I love crypto in general. Like that's what inspired me to learn how to code. I learned it from like YouTube and just like sitting here unhealthily grinding out till I figured it out, and I haven't turned back. So it was really a great opportunity to kind of like in a sense give back to those that are interested in solidity and learning how to like navigate this crazy space. I wish there was a guy like me that went out and did a workshop when I was learning. So, returning the favor. So today, uh, I'm assuming that you guys have finished the token contract where you're able to deploy your token. We'll refresh that as well, and then we're gonna learn the next step on that. In like the Lego block is like what can you do with your token, staking it. Right. I made a quick slide, and of course I've lost that slide image. Oh, here we go. It's really quick and very quick. I don't like PowerPoints. I like getting into the nitty-gritty of everything, but a staking contract, right? Using your token to stake. Couple concepts that we want to cover in it because we've made our token whatever we want to call it, and it's sitting in our wallet or it's sitting in the smart contract. And it's like, well, what do we do with it, right? So like we want to be able to have some kind of functionality of our token, right? Like we made the contract and we don't know what to do with it, right? We just deployed it with our name or our business or our idea, and we're just sitting there. Now what, right? So we're gonna add another smart contract that's going to interface, and I'll get into that interface our token. So then we can utilize this token in this new contract, right? And so a lot of misconceptions happens of like the way we have to do allowances in contracts. We don't necessarily send tokens to a contract. We give permission for a contract to take it from our wallet or our possession, right? So I'm not sending, USDC to like this staking contract. I'm saying, hey, contract, you have permission to take, $100 or $1,000 from my balance into the contract. So we're going to cover about like how the allowance works. And then your contract is going to then hold the tokens, and then we're going to find a way to generate value, and then we're going to find a way to deposit it, right? Why would I stake my tokens in your contract without any value, right? So those are the pretty much the concepts that we're going to have in here. And so for those that are watching, I did post a couple gifts that you can follow along. I'm just going to repost them again in the chat here on the side. Let me just get rid of this, and they will look like this, which is a standard token contract. I know it's really small, and then another one that has a really long staking contract. I know it's intimidating, but we're going to break it down. We have like a whole hour here, so we're going to break it down piece by piece. Do not be afraid to ask questions in the like the chat channel. I will stop. Put your hand up. Doesn't matter if anything. I'm actually going to turn off my camera, so then I think the stream might be a little bit better. But let's go ahead and just start off. We're going to do a review on the token contract for those that may have missed it, and then we'll get into the staking. Right. So right here, if you go to like the Wizard Open Zeppelin, let me just go ahead and go that really gets you. Actually, let me go on to another browser here. It's just a little bit quicker because I have that saved. Wizard.openzeppelin.com. They have templates, and I'll paste that in here. They have templates for you to get started to have like a base contract. Right here, it's a really great resource for anybody that's kind of curious about starting your own NFT or your own token. Right, so it's kind of already built out. It's going to ask you if you want it mintable, if you want it burnable, if you want to be able to pause a token, if you want votes, things like flash minting, if you want to do upgradable contracts. You see, it just keeps building it out for you. It's pretty complicated with a lot of concepts, but we're going to break it down to have it really, really simple on here where we just have some tokens and we're going to mint them, right? So we're just going to be able to mint the tokens and we're good to go. So you can always go to the wizard.openzeppelin.com just to kind of generate your own token or your own NFT project or your own 1155 NFT project. It's a great tool for anybody just to play around with and get familiar with it. But I've already kind of done a very, very basic one for you with this basic token. And so we have in our Remix, and I think you guys have used Remix before. If not, I can talk about Remix if we need to, but I'm going to assume you do. And we're going to have our contract that's just going to be called token.sol. and I just copy and paste the token contract here. And so what we're doing is we're utilizing the Open Zeppelin contracts, the ERC20. Basically, if we don't have a standard of tokens, everything gets chaotic, right? We don't know like how to send a transfer. We don't know how to keep a balance, right? So Open Zeppelin has helped us create a standard for us, so then we don't have to really deal with it. And then we just import all those tools in, and we can easily make some tools to just start using our tokens right off the top, right? There are a few other standards out there, but they're not as popular. So like if you want to interact with other contracts and whatnot, and they don't follow the same standards, it's going to make your life semi difficult. So, Open Zeppelin seems to be the golden standard for all tokens and NFTs and whatnot. So it's a great resource to look at for all tokens. Right now, for those learning Solidity at this point, we have done a transition from Open Zeppelin 4 to Open Zeppelin 5. So if you are looking for a lot of tutorials out there from last year, a lot of last year's tutorials may not work because those were built on Open Zeppelin 4. And with the new Open Zeppelin 5, there are breaking changes. So if you're trying to practice or trying to do a few things, I had that problem with Solidity V7 and V8, which is it is now. It's just one of those things that like you have to ask around or look why it's breaking. So when you're trying to learn and experiment with stuff, I know that can be frustrating. There's always breaking changes with every new version. So, it's just one of those things. So, anyways, for a recap, right? We're importing our ERC20 because we want to make a token, right? And we are going to have our contract, which we call any name that we want, right? So we're just calling it my token. And we're making sure that we're importing this library. And we're going to say we want to use this ERC20.so file. So we're going to make sure our contract is also including this ERC20, right? And so when we make our constructor or like that, the constructor is the first thing that runs when you deploy the contract. It only runs once. So it's you kind of load it up with whatever you need to be like just ran it the first time. That could be setting ownership, that could be distributing tokens to certain amounts that are locked away or anything you want, right? It just knows that once you deploy this contract, it's only run at one time. And so it's saying, what is the name of our token? So I'm just calling it my token, and then I'm giving it a symbol. You can rename this token to whatever you want. I can make it Billy Jitsu token and then BLJ or whatever you want. You can make it as long or as short as you need to. But it's just the way you name your token, and then that's what it could be recognized on the block explorer. Here we have built-in functions from this ERC20 contract. We have this underscore mint. That's a built-in function on the actual contract. Cool thing about Remix is when you put your mouse over the function and it's built in the library, it'll take you to the quick function that's built in here. So we know this function mint takes an internal address account and a value account, and then it's going to do something. So what we're doing is we're saying whoever deploys this contract, we're going to mint the person or the wallet that deploys that contract, and we're going to give them 1,000 tokens of this. And so 1,000, everything's in 18 decimals in Solidity. So we instead of adding like an additional 18 zeros in here, we can use 10 to the 18th power. So I want 1,000 tokens, but it's in way, so we have to put 10 to the 18 power. And then I also made another function out here because this is only run once. And then if we only run once and we don't put this in here, it's only going to give us 1,000 tokens, and we can no longer print anything more because the smart contract is immutable. We won't be able to do anything more with this contract other than the 1,000 tokens that we have. So I created another function that just called mint. And every time we hit this button, it's going to mint us another 100 tokens, 10 to the 18, right? So far, so good. Are we doing okay? I'm gonna say no news is good news, and I'll just keep it going here. So just to keep it simple, we're gonna go ahead and just deploy this contract. So and anything on Remix, you're gonna make sure you have it, you highlight the token or the contract you want to deploy. We're gonna go to the compiler. Right now I have an auto compile, and so I'm just gonna go ahead and compile the token. It's gonna make sure that we don't have any, misspellings or compiler errors, and then we're going to go ahead and deploy this. Now, for right now, for testing purposes, I'm going to deploy it right here on Remix, and we don't need any testing tokens. You'll see that I have a whole bunch of wallets. They give me all this fake ether, so I can like run the simulations and do anything. It's pretty quick. So we're going to go ahead and just deploy this out, and voila. So our token has been deployed, and we have this unique contract address with this like D9, this interesting thing. So we can open this up and we can look at all the functions on here. You'll see that I only have one function here, but I have a whole bunch of functions in here. And those are from the ERC20.sol library that we have all these additional options and functions. That's why like it's not recreating the wheel over and over again. There's libraries that already have the stuff we need, right? And so our function that we made is this mint function. But one that I want to show you is the balance of. We can say who owns what, right? And so we deployed our contract, right? And remember when we deployed it, we had this mint function that says we should get 1,000 tokens. So by default, our wallet should have 1,000 tokens. So if we go up, I'm going to go ahead and grab this wallet address because this is the one that deployed out. And remember, each one had 100 ether, but it cost me a little bit of ether to deploy the contract. You got to pay the gas to play the game, right? So we're going to go ahead and copy our wallet address. I'm going to put it in the balance of. I'm going to go ahead and paste that down, and I should have 1,000 tokens to my balance, right? And there it is. So again, everything here is in 18 decimals. So if we go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8. There we go. If we subtract that, we'll have 1,000 tokens in our balance, right? So we're good. We have 1,000 tokens. And then if I hit the mint function, right, I should have 100 more tokens, right? And that transaction went through. So if I hit the balance again, I should have 1,100, 1,100. And then if I hit mint again, I should have 1,200, right? And so it just keeps going on and on. Again, this is not safe practice for anybody that would want to do something because you want to have limitations, right? You don't want to have infinite tokens because then they wouldn't really have any value. So you would put some logic to get that going. But that's pretty much straightforward of like running your own token, being able to deploy your own token, being able to distribute to whoever you want, right? Like if we wanted to make sure like there was a button on here that would distribute to somebody else, like maybe a faucet, we can add in some kind of argument, like we can say an address, and that can be the requester. And then on the requester, then we can, just put in the requester here. And so the person or the wallet that is requesting the did I spell that right? Oh, as I'm talking and typing. So the wallet that we are sending it to is the one that will receive that wallet, right? So I'm gonna go ahead and just get rid of this really quick. We're gonna destroy this contract and no harm, no foul. And I'm just gonna redeploy it again. So I'm gonna compile it because I made that change. I'm gonna redeploy it. So I'm gonna deploy it. And if I grab this wallet address, I'm just gonna make sure that my balance started over again. So I should have 1,000. Right? So I'm back to 1,000, right? It's a brand new contract. We just cleared it out. But now this mint doesn't take just a button, it requires an address, right? And so now I have to fill in this address with the requester. So just for fun, I'm going to go ahead and grab this next address here. I'm going to go ahead and copy that over. And I'm going to check the balance of just to make sure it should be 0. And yep, I have nothing on here. Okay, so I'm going to paste this down as the requester. I'm going to go back to the original wallet. So I'm saying, hey, I want to send this address 100 tokens, right? So I'm going to go ahead and transact. And so that transaction went through. Everything looked good. Let me just grab that address again. And I'm going to put that balance or check the balance here. And I should have 100 tokens. Yeah, like one less zero, basically minus the 18 decimals. So you can modify your token contract to do different things, right? Whatever you're thinking, you can set requirements. Maybe they can only claim once a day, so you can set limitations, or once per wallet, any way you want to go forward with that. So just wanted to kind of like recap the token system, but for right now I'm just going to do just the message.sender. And just in case, message.sender, for those that don't know, is, or if that's confusing, is that's the wallet that requests or calls a function. So there's no way to know the address of something when we're requesting from it. So message.sender is a default solidity value that we use to know that this is the wallet that's doing the request, or the original wallet doing the request. So let me go ahead and go back to that major wallet. So if I were to call the function from this one, this would be the message sender, right? If I were to call a function using this wallet, then this would be the message sender. So like whoever is the wallet that does a request, like from your MetaMask or anything, that is the message sender. So like if someone's minting something, like minting an NFT, we want to send the NFT to the wallet that paid the fee for the minting. We're going to send it to the message sender. That's the one that's sending it over. So I'm just going to redeploy this just to have it out here. And so we have our token contract with the mint function that works. Awesome. Okay. Hopefully we're good. I'm not leaving people like confused with it, but we're going to get into the staking contract. And there's a lot of information on here, and I'm going to do it one by one. We're going to break it down before we even like get into the details of anything. And I know this is a little scary. Let me just make this smaller and really focus on the text. Is Let me know if the text is decently large on there. If that's readable, I'll give it a second. If it's no news, then I'm going to say okay. And I think we're good. Okay. So, we're going to follow kind of the same format that we have, right? We have this constructor. We have a few more functions, right? Instead of just having the mint, we have all these extra functions. So we're adding a lot of different options for our staking contract. Awesome, good to hear. Um, and so we've added quite a few more options on here, right? So we can import quite a few libraries on here. Remember, we did the ERC20, right? And here we're doing the ERC interface. There's ERC20. So I'm just going to compare that. We were importing the ERC20, and here we're importing the interface of ERC20. What that means is we're not going to be minting out tokens. We're not going to be using a lot of those libraries. So we're going to make our smart contract a little bit smaller because we don't need the full functionalities. We just need to reference stuff from the token contracts. So the larger your contract is, the more expensive it is to deploy. So we have to find ways to make it as small as possible. It gets pretty large. In the 2020 bull run, like doing a transaction and applying a contract almost cost like literally like $1,000 to $1,500. It was an insane time. So in order to really save money and really make it smaller, we found ways to like really keep the library size down, right? We're also bringing in another library called Ownable, right? Because when we make a contract, right, we want to have functions that only we as the owner can call. Let's say we're selling NFTs, right? And then we want to find a way to withdraw the ETH that we earned in that contract. We don't want to let anybody just withdraw it, right? We only want our wallet to withdraw it. So we have this thing called Ownable, and that gives us the power to limit that. So those are the two different imports that we have here. And so because we're interfacing and we're not bringing in the whole library, you'll notice that in our contract name, and just to make that small, just in our contract name, it's just is ownable. We're not doing is ERC20 like the token one, right? Because we're bringing in that whole library. We're not. We're just referencing, and the only full library we're bringing in is the ownable library. So that's why our staking contract name is ownable. All right. So let's get into all the details of what all this is, right? So I'm going to skip this for now, and I'm just going to go through the concept of what we are trying to do, right? So let me go ahead and bring this this paint here, or you're going to see my horrible paint job. But we have our token contract, right? We just have our token, and we'll just say T for token. And I'm horrible with drawing with the mouse, right? And so our token's just sitting there, right? We have 1,000, a million, whatever we want, and we want people to deposit into our contract, right? This is our staking. So I'm just going to put a stake contract, and so we have to add a function for people to deposit, right? We have to let people deposit. So I'm just going to put DEP, and we need that to be able to bring their tokens and put them in the contract, right? And then we need people to withdraw. So we need a W. This is horrible. WT. I'm gonna get like a computer that like I can draw with a pen, but we need to be able to withdraw and then return it back to the owner, right? So we need those two functions for sure. So when someone deposits, we're going to need a way to keep track of how much they deposit, right? How can we tell the difference if someone deposited 10 tokens and someone deposited 10,000 tokens, right? So we're going to have to find some kind of like logging system or some kind of way to do that. We do that with a mapping, and I'll explain that in a little bit. And then, when we withdraw, we have to make sure that they do a balance, right? Like a banking, right? You have debits and credits, right? You do a deposit, your balance goes up. You do a draw, your balance goes down. And then why would anybody want to deposit anything into our contract, right? We have to find a way to reward them, right? And so how does anybody get rewarded for depositing their tokens or anything like that? You kind of get some kind of like incentives. Like a bank would give you yield on your dollars, right? Like if you put in $1 million into the bank, what's the point of putting the $1 million if you're not getting rewarded for it? So they give you like some kind of percentage increase, right? Like maybe 5% on a locked rate or something like that. So at the end of the day, you come out with a little bit extra. So we're gonna have some kind of reward function to say, okay, if you deposit with us, and then you'll get some kind of reward, keeping your tokens together. So we'll have some kind of reward function. And then when you draw, you get extra rewards on there. So that's going to be the basic layout, right? We want to, have a deposit. We're going to keep balance of like who's depositing. We're going to give the ability to withdraw, right? And then we're going to give people to reward that to have usage, right? And so that's going to be the flow of our contract. And that's what we do. So let's go ahead and swap this over. All right. So just to break this down little by little, we're going to do that something right here. So we're going to stake, which is basically our deposit, right? We're going to unstake, which is basically withdraw our tokens. We're going to find a way to calculate our reward because we want to be like, okay, how much did you deposit? How long did you deposit for? And then we're going to find a way to set that reward weight. So what it means by that is like, okay, well, what rate are we going to reward you? Is it going to be 5%, 10%, 50%? What are you going to make? Right. So that's pretty much deposit. Let me just make the comments on here so it's just a little bit better. Deposit, the withdraw, the rewards, and then the reward rate. What's the what is the rate at which the reward is awarded? Cool. All right. So, like we said before, when we deposit or stake something onto a contract, we need to find a way to keep track of what is, who's depositing what. And so that's why we get into the mapping, right? So I'm going to scroll up just a little bit and we have something called a mapping. So we want to be able to keep track of two things in the staking contract, right? Because we want this reward. Let me move this. I lost this picture here. One second. Right? When someone deposits, we want to keep track of how much they deposited and for how long, right? So we're going to have to find a way to keep this all together. So we have this address, right? We know the wallet's address, right? Because that's the message sender. So we want to have the address and we want to tie it to something called a stake, right? So I think you guys are familiar with like UN256 and strings and whatnot for types. So when we want to mix two types together, right? Because we want to know the deposit and the amount or what time they deposited, we're going to have to build something called a struct, right? So I'm going to expand this. And so we're going to create our own type of variable that has two numbers, the amount of tokens that were popping in, and when did it start, right? If I did it yesterday, I need to timestamp that so I know how much to reward you if you try to pull out your tokens today, right? And based on the amount, that's how much I'm going to reward you. So we have this mapping. It's like, okay, this wallet address deposited 10 tokens today at this time. And we're going to keep this entire like database of mapping in a public called stakes. So that way we know who deposited, how much, and what time. Think of it like a cell phone, right? So like mapping is like a cell phone. If I typed a name, I want to see that number, right? Like whose number is this? So if I typed in the name, it'd be like, okay, here's their phone number on there. So that's how mapping works. I put in one address or one point of reference, and it'll return back something in return. Right here, we're doing it for our stake, which again is the amount of tokens we're doing, and the time it actually started depositing, right? We want to reward the people that started earlier with a much bigger reward than someone that deposited last minute, right? We don't want to have that like last minute because it'll be abused. So we also want to have our reward rate. It is the tokens that we're going to reward per second staked, right? So we have to see how much are we going to reward our users, right? Is it a 5%, 1,000%? How are we going to incentivize users to deposit in our contract, right? And so that's how we're going to go ahead and start our two variables. Now, I'm going to come back over here into this IERC public thing, and this concept took me a long time to understand. And so hopefully everybody's kind of like on page with me right now. I think we're kind of straightforward. So I'm just gonna recap this really quick. So in order for our token that we deployed here, right? We deployed this earlier. We've been playing with it. We maybe been giving it out, right? We want our contract, like, it doesn't know it exists at all, right? They have no ideas that any other contract exists until we interface them, right? And so in order to interface the contract, we have to create something called an object, right? And so Open Zeppelin has created this standard default interface for the ERC20 token. So it knows what to expect. It has the mint function, it has a transfer function, all these different functions that we had. Let me just expand this just a little bit so you can see all these functions, approve, transfer from. It knows that these functions exist, right? Once we interface it, because if we interface it with blank, it doesn't know any of this exists at all. It doesn't. They're just dumb smart contracts, right? So we want to make sure that we let the contract know that we're interfacing it with an ERC20 token, right? And we're calling the interface, we're just giving it a name. We're calling it staking token, right? That's our token, whatever we want. Now you can call this anything you want. We're just letting the contract know that the staking token is the way we're going to interface our token. You can have 100 of these, right? Like you've seen contracts that take USDC, wrapped ETH, wrapped BTC, right? We're just doing it for one token, but you can do quite a large amount of tokens that you want. But you want to make sure that you're saying, hey, contract, we're going to interface with an ERC20 token standard, and we're going to give it this name, right? And again, anything you want. Hopefully that makes sense. That took me a long time to absorb and like understand in total. So just know that if you want to interact with another contract from your contract, you have to find a way to interface it so it knows what functions exist, in short. Okay. So as we go down here on the list, we have these events. And so the events are good because they just broadcast on the blockchain. They broadcast things that are important to you, right? So for us, our contract, we want to know when someone has staked, we want to know when someone has unstaked, and we want to know if someone has got a reward they paid out, right? Also, if you're working with a front end developer like the website, they're going to be doing something called event listening, right? So if something's staked and you click the button on a website and it's just waiting for the transaction to go through, you want something to happen on the website to let people know, hey, your transaction went through, everything looks good, right? Otherwise people are just kind of like stuck. So it's listening for the event that says staked. Oh, if the staked event happened, it's going to say, oh, your stake was successful, right? And then it lets the user know, hey, all right, everything's done, I'm good to go, I can leave the website, I can do whatever I want. So for anything important, you want to create these events to let people know, hey, this exists or this happened. It also is logged in the Explorer, and we'll talk about that in just a little bit. And so you can make these events with as much information as you want, right? So for us, we're just saying, hey, we want the address of who deposited, and then the amount they deposited, and that's it. And then if they unstaked, the who requested the withdrawal and how much did they withdraw, and then any rewards, who got rewards and how much did they get rewarded for. So a pretty straightforward, event system here. So let's get down into the constructor. How do we like what's the one liners that we're going to do? Okay. So our constructor is going to require a few things. Okay. So it's going to require the address of the staking token. Now, what does this mean? It's okay, when we deploy this contract, we want to interface with our token, this token, right? So we're going to need to know the address of this token. And remember, we launched it, and so we have this smart contract access right here. So I can grab this wallet address and then put it into my contract when we deploy it. But let's come back to that in just a second. Oops, make that smaller. Right. So it's going to say, okay, what is the contract address of our token? And then this initial owner, and this is new to Open Zeppelin 5. This is a requirement of the only owner ownable function call. So it wants to know who's going to be the owner of this contract. By default, that used to be the one that deployed it, but to make things easier, this is going to be the initial owners, which is going to be our address, right? So it could be message center, or we can send that to somebody else, but it does require us to label ownable with whoever we want to own the contract. And for our purposes, it's just going to be our wallet, right? And so now we have this information, we're just going to run everything. So we can have a requirement. And this is how we can set limitations on our smart contract. We can do requirements. And so I want to require that if the staking token is zero, like 0x000000, it's basically doesn't exist. So I want to make sure the staking token exists before we deploy this contract, right? Like if I put in the wrong address of something that doesn't exist, don't deploy it. Save me the gas because that won't work, right? And then here we're taking this address of this token right here, and we're interfacing this address. We're saying this address that we have here at token.sol that we deployed is going to be interfaced for the ERC20 token, and we're going to label it this staking token right here. So we're just setting that this interface for the address is here. So like this staking token, we're putting it in this object. So like the contract itself, this entire token contract, this entire thing is now valued in this staking token right here. This value right here in our contract, and then we're just setting the reward weight rate to one, and that's just for instead of doing all this complex math and whatnot, percentage and everything, we're just saying, okay, it's one. That's what you get when you deposit whatever time block it happens. For every second, you get one token. Okay, hopefully we're good. I'm not overwhelming you. We're going to break down the staking portion, right? So now we've deployed our contract. We've now said, okay, this is going to be our token that we're going to interface with this our token. We're setting a reward weight of one, and we are the owner of our contract, right? So now we want to have a function to deposit. So let's go ahead and drop that down. So when we stake something, we want to ask the user, well, how much do you want to deposit, right? We want to say, oh, do you want 10 tokens, 1,000 tokens, a million tokens, whatever you want, right? We want to make sure that we require that they have at least one token, right? We want to make sure that they don't deposit zero because it's pointless, right? They're just wasting gas. So we want to make sure there's a requirement that you have to do anything more than zero. It can 0.00001 token, but as long as it's not zero, you're good to go, right? And so now we're going to call this token contract. Remember, we set this to this object. We're referencing our token.sol deployed contract in this variable. So now we're saying we want the staking token. We want to be able to call the transfer from function. And just to recall that, like, where does this function come from? It's from our token.sol. Let me expand that. And our deployed. See, we have this transfer fund function that's built into the contract, right? So we are calling that. Let me make that small again. We are referencing it and we're doing the function of. So we do the object or the contract dot and the function. And we want to transfer from the person that's calling the message sender to this contract. And so we don't know the address of our contract because we haven't deployed it yet, right? So the way you reference your smart contract is address this. That way, when it deploys, it knows it's this contract that we deployed. It's just we don't know what the address is going to be yet, right? And then the amount, right? So we're going to transfer it from your wallet to this contract, and this is going to be amount that you set right here, right? So we want to do 10 tokens, that's going to be 10. If 100 tokens, it's going to be 100, right? And so now we got to keep track of who deposited and how much, right? So remember we had this mapping, right? And so we want to update our mapping, and it's called stakes. And so because our mapping has two different functions or two different variables in it, we want to make sure that we get the right ones. So we want to make sure that our address, remember this is how we reference it, the address. So our stakes address dot amount, because we have the amount here, is equal to the amount that we deposited, right? And so This plus equal is just a short version of, let me just do the stakes message sender dot amount is equal to stakes message sender dot amount plus the variable amount. So you see it's much, much longer. So we just do the short one, we're just plus equal because we know we have this value and we're just adding amount to it. So this is the shorthand version of what this is. So imagine typing this every time. So we just have these shorthand versions on there. Right? So we want to update the amount and then we want to start the time, right? And so we're going to the stakes message sender. Again, it's the address and then the start time and then block timestamp. So the way Ethereum does or Solidity does time is the timestamp of the current block. So if we just check Etherscan really quick as an example, we can see that the current block that happened 13 seconds ago is 192.70.440, right? And it just keeps going up one block at a time and it just keeps going. This is how we keep time track in Ethereum. So we want the current block timestamp, which is right now. When you call this function, that is the current timestamp right now. So it knows in Unix that this is it is. So this is how we keep time on here. So now when we make this deposit, we want to make sure that there's more than one token or more than zero, right? We transfer the tokens from our wallet to this contract for the amount that we set and we update our balance, right? So now we have our balances updated. So we've deposited 10 tokens and we deposited just this very second. And now we want to emit that event saying that our wallet staked this amount and that goes up to this staked amount event and that broadcasts it out to the blockchain and the internet and everything to say, hey, we've deposited, right? So far so good, hopefully. So the logic is very similar. So deposit the tokens into this contract, update the balances, right? And so now we want a function to withdraw. Right. So our tokens are in, just so we know where we're at. Our tokens are in this contract. They're sitting here in this contract. We have all our tokens. We want them back, right? If we don't have a function to get them back, they're locked here forever. That's true for every smart contract. All the horror stories of people getting locked in contracts, that's one of them because no one made a function to get them back out. So we have to draw this withdraw function with this unstake, right? So this is how we get our unstake back. We have to remember, we have to keep track of the amount that we did. So when we make this call, it's saying our wallet is requesting it. So we're going to go to stakes and message sender, right? For this mapping, right? We want to say how much did we deposit? It's going to go to the amount. And so what we do is we set this amount to a variable here. There is gas technicals that make this a little bit cheaper. Sometimes it's not the best programming system, but in order to make it cheaper function calls, we kind of do this. We save the stuff that's stored in the contract to local memory. So then we can use the local memory to be a little bit cheaper in the transaction. You could use this value as well to see it, but it's a little bit cheaper and a little bit easier to say, hey, this value, whatever it is, 10 or 100, save it to this variable so we can use it. So that's why we have this little function line here. And so this staked amount is what it is. So let's just pretend it's 10. We deposited 10 tokens. And so we're going to check, is the stake amount greater than zero, right? If they have withdraw already, or there's malicious characters that are trying to like take money out of the contract, we want to make sure that their balance has something so they can't take anything out, right? This is how hacks happen or something. Somebody leaves this out, and now anybody can withdraw from the contract if they have no balance, right? So we want to have these checks and balances with the requires. And so for right now, we're going to skip this. This is how we're calculating the reward, right? So I'm going to just comment it out just for a second, and it's going to break the contract. But we're going to update our balance to zero, right? Because we're not saying how much you want to withdraw. We're just doing an easy function. You're going to withdraw your entire deposit. So we're going to make sure, okay, this person is withdrawing their entire amount, so their balance is now zero because I'm going to give them all their tokens back. right? And then we're going to transfer our tokens, right? We're going to transfer it to our wallet address for the amount that we have staked that was our balance here. And so just ignoring this for right now, that's all it is. So it's kind of like, all right, I want to stake my tokens. We find out what's the balance of my account, right? Make sure it's greater than 0. We're going to set our balance to 0 to make sure that we're zeroed out, and then we're going to return those tokens right back to you, right? But with our function, we want people to get rewarded. We want to add some kind of reward system on here, right? So I'm adding this line for reward, right? And so the reward is going to calculate reward. Where does this come from? We haven't theoretically made it yet, right? So we're going to go down into this function. Now, functions can call other functions, and we want to have a quick reference, right? We don't want to stick all this code into this function because then it looks really like messy. So we want to like organize and structure it. Like imagine having like a file system with like A, B, C, D, and then you start throwing like the Z's and the A's, and then it just gets really hard to like flow in that file system. So we make functions that can call other functions to reference, right? So what we have here for this calculate reward is we want to figure out how much we want to reward our user depending on how long they've put their assets into our contract and how long did they hold on to it, right? So we have this check like if the amount is 0, don't even calculate it, right? Because they haven't had any deposit whatsoever, so no need to calculate it, just end the contract. But what we want to do is we want to get how long they've staked, right? So we're going to get the staking time is what the current time is right now. Again, remember we staked maybe a minute ago, right? So there's been maybe 60 blocks that may have happened. That's an arbitrary number. Don't quote me on that. And so we want to get the difference of what the current time is now minus the time we started, right? And the way we keep that is again, we have that stakes mapping, right? On the very top, we had that stake mapping that had our start time in there. So if we go back down, you can see that we have stakes and the user, which is our address, which will be our address actually, and then the start time. So start time of our address versus the current time, whatever the difference is the amount that we actually staked for. So whether that's been a week, a day, a year, it's going to calculate that difference time. And then we're going to do a little bit of math saying our reward is how much they've deposited with its 10 tokens times the amount of time they have staked and then the reward rate, right? Remember, we had like one for it. It could be 5%, 10%. If you really want to do the math and get like a really fancy one, you can adjust this. Here, I made it really small. That way, or like really fast. So when we deposit it in the test, you can see, the reward come instantly, because sometimes it's like 0.000001. We can't even see it, right? And then it's going to return the reward for us. It's like, all right, we did the calculation, this is what it is, this is what the reward's going to be. So then if we come back, you'll see, hey, let's calculate the reward for the person requesting. So we're passing in the address of the wallet. It's coming here, it's doing all the calculation, and then it's going to return back a reward value. And that's why we have this reward to catch that value that it returns to us. So anytime a function does a return, it's going to let you know that, hey, there's a UN256 coming back at you. There's a number value coming to you, and we're going to catch that reward here. And then we can calculate the rest of our stuff here. So let me go ahead and do this. And so if the reward was so quick, or like I staked and unstaked, if the reward is 0 or anything, we're just going to skip it. But if our reward is greater than 0, like if we get a token in return, we're also going to call the token transfer and then reward our user with this reward value, whatever that is, based on this return. And then we're going to also emit that the reward was paid. If there's no reward, we skip this whole thing, right? And then we just jump into the reward on staked. But if there is a reward, we'll emit two events: one that the reward was paid, and that we've unstaked, right? Hopefully we're good so far. And then this final part right here is just for us. Just wanted to show you that we have this only owner modifier at the end of our function here. You'll notice that none of the other ones have that right here because it's global for anybody else. Like anybody can call these functions, but this one function is the one we want to limit. We want only the owner of this contract to be able to modify it, and that's the reward rate, right? How much do we want to reward our users? We have the power to change that at any time, anytime we want. And so we want to just set our reward rate to something new, right? So if we had a reward rate of 1, You'll see here that we set it to 1. If we wanted to change that, we could change that to 5, we can change it to 0, we could change it to 1,000, whatever we want, and that's gonna incentivize users to, like, start depositing tokens into our contract, and we can do something with it. So, what looked really, 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 big and scary, hopefully I've broken down into piece by piece. We have our constructor, we have a function to deposit, a function to withdraw, and a function to calculate our rewards, and then a function to change our rewards if I need to, right? So, so much talking, let's actually see it in action, right? And so now I'm going to go to my staking contract. We're going to go ahead and compile this, right? And we're going to want to deploy it. So let me just minimize. This is our token that's been deployed, right? We want to deploy our contract. You'll see that it requires two arguments. Remember, in our constructor, we needed the address of our staking token and who's going to own it. So this address of our staking token is the one that we deployed, our my token. So I'm going to grab this contract and I'm going to go ahead and paste that. And then who's the owner? I'm just going to grab my wallet address and say I'm going to be the owner of this contract. And then we're ready to deploy. So I'm going to go ahead and transact and I'm going to open that up. And that looks like it was successful. All right. And so you'll see that I have my token contract and I have my staking contract. All right. So let's go ahead and open that up. And you'll see we have all the functions that we have, the stake, the unstake. We can set the rewards, right? So let's go ahead and make some magic happen here. So now we want to stake some tokens, right? So let's go ahead and just pop some tokens in. So we're going to stake our contract, or our wallet has, let's see what our balance is here. Let me just copy this. Balance of our contract is 1,100, right? So let's just do 10. And so in Remix and in Solidity, remember we have 18 decimals. And so we're going to go 10. And then remember, we have 18 decimals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oops. That wasn't good. And so now we're going to do 10 things. Now, this is going to fail. And hopefully someone is red flagging it and say, hey, it's going to fail. We're going to ask why, but let's go ahead and transact. And you'll see that it has failed. And so right here, we're going to get all these different errors on our block explorer, right? It says basically reverted, didn't work. It says insufficient allowance, right? Remember, we were talking about the way contracts work with each other. We're not sending tokens to the contract. The token is the contract is trying to take the tokens from us, but we haven't set an allowance, right? So in order to give an allowance, we have to talk to the token contract. And you see a lot of people kind of get hacked with this, right? Because they do these malicious contracts and they allow the contracts to take it from them. And they say, "Oh, I got hacked. I got hacked." Well, you have to approve the contract to take the funds from you, right? So we want to approve our staking contract to take our balance, right? So in our token balance, we want to approve this contract. So we're going to go to our deploy contract, which is this address here we deployed. We want to go to our token contract and say, hey, I want to approve the staking contract to take this much from my balance, right? And right now we did 10, right? But let's just do 100. So we're approving more because in the future we're going to deposit a little bit more. But in good practice, you only want to approve the amount that you want to have deposit, right? Because the contract can take it at any time if it's malicious. But again, it's 18 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So now we are approving this contract to take the tokens from us. So let me go ahead and minimize that. And so now when we run this function to stake and take our 10 tokens, it's going to work. So I'm going to go ahead and transact and voila, it actually works. So now it is taking the 10 tokens from our balance and inputting into the contract. And the way we can check that is to copy the address of our staking contract, go to the my token, check the balance of this contract, right? And so if I paste this down, check the balance, it should be a little bit smaller zeros with just 10, right? So we just have the 10 with the 18 trailing decimals. So now we know our token has 10 of ours, right? And if we look at the details, of our mapping, which is the stakes, right? If we go into our address, remember we did this mapping here that keeps track of our balances and the amount or the time it started. If we go down to the bottom here and we go to our stakes and we pop in our address, we should say, there we go. We have our 10 tokens deposited minus the 18 decimals and the time that we deposited, right? So that way it keeps track. If we add more, it'll add more. So let's go ahead and drop another 10 in here. I'm not going to change it. I'm just going to say put in another 10. Remember, we approved our contract for 100. So I'm just going to pop in another 10, right? And so now my balance should increase. And so I have 20 tokens installed in here, right? And so if I want to calculate the reward, I can just pop in my address here. Let me just make sure I have that wallet address copied. And I'm going to calculate my reward because remember, we did that function where we can calculate our reward. We can see where our reward's at, and I get 48 tokens. Right now, if I were to try to withdraw this, because I wanted to make this reward super high so you guys can see the reward that I get. If I wanted to withdraw it, there's not enough tokens on the contract to pay my reward, right? Because I have 20 tokens in the contract and there's only 20 tokens in total because no one else has deposited, but I'm rewarded 48 tokens. It's not going to work out, right? Because I can't pay my reward and return my tokens. I need 68, right? So it's not going to work out. So just to fix this contract, I'm just going to transfer some more tokens into the contract just for demo purposes, and it's because my reward system is really, really high. I just wanted to have that on there. So we're gonna transfer that, and I'm just gonna do like 500 tokens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, and just balance that over there. So now when I withdraw or unstake my tokens, I'm gonna get my reward and my tokens back. So I'm gonna go ahead and unstake, and that went through. So we can look at all these events on here and see everything that's happened. Our transaction hash, which is like unique to each transaction we do, the block number, who it was, my wallet address, how much gas it cost. But what we're looking for is the logs, which is our events, right? And so we did a transfer event. It transferred another event for our tokens. We have our reward paid, right? We have our reward paid event, right? Which is who got paid and how much, right? So if we go into the reward paid, you'll see that it was my wallet and this was my reward, right? And then right here, it's unstaked, which is this unstaked one here. And you see that the who was this wallet unstaked, which was me, and how much I unstaked my 20 tokens, right? So you'll see that each one is going on there. All the pieces are kind of like coming together for the staking contract. And yeah, that's pretty much it for the staking contract of being able to deposit and withdraw and then give some kind of reward to the user on there. Now, you don't have to have the same token. You can, make it mint other tokens. A lot of people like, do their own tokens, like when there's a new token launch or something and you stake your USDC for their token, right? There's different ways to approach this, but the functionality is exactly the same, right? You need a way to stake, you need a way to unstake to be able to take it out, and you want a way to reward them. And the most important thing is you have to keep track of who deposited what and how long, so you know how to reward them. So that's like literally right at the hour on there. If there's any questions or anything, again, the exact copy of this code is in the gist of the things I just posted on there. But yeah, that's how you do a staking contract.
Wow, that was very precise. Thank you so much, and great explanation of everything. Thank you.
Thank you. Thank
I
you.
think we are about to have one question. Whoever also wants to ask a question, like to speak, feel free to request to speak. To do that, you just need to click on your emails and then request to speak. And then I
Mhm.
can add you as a
Yeah.
speaker, or you can write your questions on the side.
Yeah. Okay, there we go. Yes. Actually, it does. So there is a yes, you're right on point. I did for simplicity. I didn't do like all the logistics of caking. So like if I stake, right? And what Gadir is saying here is like if I stake, there's no way, like, if I say I did a million tokens, right? And I put it, there's no way to keep track of what you staked before because the amount here overwrites what it is. So if you did a million tokens and then you did 10 tokens, it will increase the amount, right? Because I'm adding the amount to here, but on the time it was, I'm not increasing it. I'm just overriding it. So like if you did a million tokens a year ago and you didn't collect your reward, and then you deposited one token today, I've erased the entire years past because now I'm updating it with a new timestamp. So what you would want to do is kind of like plus time. It gets a little bit more tricky because of the Unix timestamps, but you could always do a plus equal on there and then add more time to the start time. But you'd want to calculate the difference of the Unix time from when you deposited previously plus the time here and then find a differential. Because what you don't want to do is because there's a reward system, I don't want to deposit one token here, wait a year, and then all of a sudden drop in a million tokens on the last minute, and then have that all count as one, like I deposited a million tokens for a year, right? So you have to find a craft your way to calculate, how to keep track of each deposit at every time. So it's a little bit trickier. So like right now, I'm just overriding it for simplicity for demo purposes, but it's a lot more lines of code to see. Okay, what was the difference of time? How much value was the difference of time? And that would have taken us way past the hour. Hopefully that answers the question.
I believe so.
Right.
If you have any other questions, this is yeah, go for it, Garrett. Got it. Yeah, if you have any other questions, feel free to write them down. This chat is gonna be open if you have any follow-up questions, and then this is Billy. Would it be okay if people contact you later with other questions? Would that
Yeah,
be
yeah,
okay?
definitely. Yeah, definitely. It's a little chaotic as I'm preparing for ETH Denver this week, but I'm usually pretty quick on responses. But yeah, just in case there might be some delays in my response, but I'm pretty good. I'm pretty good with it.
Perfect. Yeah, I think we are good. I don't see any other questions, but thank you so much for it.
Of course.
Um, it was a great explainer, and yeah,
Yeah.
we are excited to see you again.
For sure, for sure. Yeah, I mean, for guys that are like, or ladies and gents, that are working on this, like the first time doing this and like figuring it out, it literally took me 3 weeks. Like what I explained in 1 hour took me 3 weeks to figure out in general of like keeping track and doing whatnot. And I only had a stake and unstake function when I first started. So don't feel like, like too overwhelmed or like feel like this was easy. I just put a lot of concepts together to be able to like, make sense of something that what's potential of what you could do. Again, there's a lot more logic to certain things to have it in a much more professional production dApp, but getting the concept down and just being able to play with it on the chain and being able to wipe and restore is really what I want you to understand on this. But yeah, if you have any questions, definitely just reach out. I'm pretty chill.
Nice. I guess I do have one question personally, which is, you already shared the resources on how people can build their skill set more. Do you have also any thoughts on what could be the resources to understand more the different use cases, maybe
Um,
to
there's definitely a lot of resources out there. I personally like, and this is kind of a competitor to have DAO, but Learn Web3 DAO is a great resource. Let me see if I can get that right here. Yeah, learnweb3.io. Yeah, this website is a great resource to get started with like Solidity and the front ends, right? Um, Academy
Mhm.
dot developer DAO com is launching their latest version here as well. They That's why I didn't recommend it first because they're relaunching a V2 on here. But these are great sources for people to learn and stuff from trusted sources. There's a lot of content out there. I mean, a ton of content, And I lost a lot of time following people that were just regurgitating stuff that didn't really understand what they were explaining. So I've lost months of time trying to like navigate through resources. And I think if you just stick to one resource, like these two, I think you'll be in good shape. And then you'll start recognizing what to look for, because if you just search up Solidity contracts, there's going to be like a million of them, right? Solidity, by example, is a great resources, but it doesn't have a lot of instructionals. It's more kind of like, oh, you want to do this one thing, this is how you do it, like, creating your first hello world out. There's no like explainer, right? It's just here's the code. So I don't think that's a good starter because it doesn't have a lot of details. Like, I want more explanation to it. Another great guy that would be good is Smart Contract Developer. It's it's um it's a lot of advanced concepts, but a lot of Smart Contract Programmer. Um, a lot of advanced concepts, a lot of beginning concepts. If you're just beginning Solidity, I would say don't do this just yet. Stick to the Learn 3 and Academy. But once you get to the point where you're feeling comfortable, there's a lot more stuff out there that's like way out there. Like the doors keep opening into like, oh, you could do this, you can do that. And so I think just with these resources alone, I think you'll be in good shape. But stick to the first two. Get your hands dirty with tokens, NFTs, and whatnot. I'm working on Academy content too, and I do Oracle content for API 3. So there's just nonstop stuff. This space moves really, really quick, and it feels like you're always falling behind sometimes, but not much has changed too much for the basics. So learn the tokens, learn the NFTs, learn the staking, and then you'll start seeing the trends that a lot of people are doing.
Amazing. Thank you very much. And yes, see you soon. And that was a wonderful workshop for everyone. The workshop and the resources, they will be gonna start later on the resources channel. And yeah, we are can't wait to see you at the hackathon as well. You can apply for the hackathon above on the apply to participate channel. And see you soon, everyone. Thank you, Billy.
Of course, of course. Glad. Thank you for having me.
Perfect. Bye, everyone. Have a great evening. And Billy, have a great day.
All right. Talk to you later.
Bye bye.